The hidden physics of ordinary life. We wake up every morning and go about our routines, brushing our teeth, making coffee, unlocking the door, walking down the street without ever thinking about the incredible laws of nature that are silently at work in each moment. Yet beneath every step we take and every object we touch, the invisible hand of physics is at play, choreographing the entire experience of life as we know it. From the very first breath you take after waking, physics is already in motion. Air rushes into your lungs not just because you want it to, but because of a precise balance between pressure and volume, a relationship governed by Boyle's law. Your chest expands, the pressure inside decreases, and the air naturally flows in to equalize the difference. It feels automatic, effortless, but it's a finely tuned mechanism based on the invisible rules of gases. As you flip on the light switch, you trigger a cascade of electrons rushing through copper wires guided by electromagnetic forces described by Maxwell's equations. That glow from your bulb or screen is the result of energy conversion. Electricity becomes light and heat. And that very light, traveling at nearly 300,000 kilometers per second, bounces off your surroundings, enters your eyes, and is translated by your brain into the colorful, stable image you call your room. Pouring a cup of coffee, you're witnessing the laws of thermodynamics in action. The kettle heats water through conduction and convection. Molecules vibrate faster and faster until they reach a boil, changing from liquid to vapor. And once you pour that hot coffee into a mug, it starts cooling immediately, radiating heat into the surrounding air. Every part of that moment is a dance of thermal energy flowing from hot to cold, always seeking balance. Now consider the act of walking. It feels so natural, so simple. But walking is a constant battle against gravity, inertia, and friction. Each step involves a temporary loss of balance, followed by a controlled fall, then a catch. Your foot pushes backward against the ground, and thanks to Newton's third law, for every action, there is an equal and opposite reaction. The ground pushes you forward. Friction between your shoe and the floor prevents you from slipping. Your muscles are constantly adjusting the angle and force of movement to keep you upright. You're not just walking, you're solving physics problems with every step. Even sitting in a chair is a physics puzzle solved subconsciously. The chair must support your body's weight thanks to the normal force acting upward, equal to the gravitational force pulling you down. The chair doesn't collapse because of its design. Its materials, shape, and stress distribution are all calculated to balance those forces without buckling. Every piece of furniture around you is a quiet demonstration of static equilibrium. Think about boiling pasta. Seems mundane, right? But it's actually fluid dynamics at work. As the water heats, convection currents form, hot water rises while cooler water sinks, creating a loop that keeps the heat evenly distributed. And when you stir, you're manually adding kinetic energy to the molecules, enhancing diffusion. Even the shape of the pot influences how efficiently heat circulates. When you ride an elevator, you're experiencing Newton's second law, force equals mass times acceleration. As the elevator accelerates upward, you feel slightly heavier. Your body senses the additional force. As it slows down at the top, you feel lighter because acceleration opposes gravity. The cable, pulleys, and counterweights all function to balance these forces while keeping energy consumption efficient. And if you drive to work or school, you're surrounded by mechanical engineering marvels. Your car engine is essentially a controlled explosion machine, converting chemical energy into kinetic energy through combustion. The spinning tires rely on torque, friction, and angular momentum to move you forward. The brakes use friction to dissipate energy as heat. Shock absorbers smooth your ride using damped harmonic motion, the same principle behind springs and suspension in many machines. Ever notice how airplanes take off with a roar and lift into the sky? That's Bernoulli's principle in motion. The air over the curved top of the wing moves faster than the air underneath, creating lower pressure above and higher pressure below. That pressure difference generates lift. And when the pilot adjusts the flaps, they actually changing the shape of the wing to control how that pressure behaves, manipulating air itself to move through the sky. Let's come back to something even more ordinary, your smartphone. Tapping your screen sends signals through capacitive touch sensors that detect the slight changes in electric fields caused by your fingers. The processor inside is executing millions of calculations per second, all governed by quantum mechanics and semiconductor physics. That voice assistant answering your questions. Speech is turned into digital data, analyzed by algorithms, and returned to you as synthesized sound. What looks like magic is a symphony of electromagnetism, optics, and material science. Even your kitchen sponge obeys the laws of physics. Its porous structure allows capillary action to pull in water against the force of gravity, much like how trees move water from their roots to their leaves. Surface tension and cohesion create this invisible tug-of-war that lets water climb inside the sponge's tiny channels. When you stir sugar into tea and watch it dissolve, you're seeing solubility and molecular motion at play. Sugar molecules break away from the crystal and are surrounded by water molecules thanks to intermolecular attraction. The warmer the tea, the faster the molecules move, the quicker the sugar dissolves. A beautiful, silent transaction of energy and structure. Even the sound of a door slamming or a cup clinking on a table is an acoustic event. Vibrations travel through air as pressure waves, reach your ears, and are translated by your brain into meaningful sound. The pitch you hear depends on the frequency of those waves, the volume on their amplitude. Echoes, resonance, muffling, all are shaped by the surrounding environment. Look closely enough, and you'll find that there's no such thing as ordinary. Every second of daily life is built atop centuries of discovery: gravity, electromagnetism, mechanics, thermodynamics, quantum theory, all converging to make your world function without a second thought. We often reserve physics for labs and textbooks, but in truth, we are walking experiments living inside a great physical machine. We ride waves of light, walk through invisible fields of force, and unknowingly solve equations with every move we make. The universe doesn't just exist, it performs. And in that performance, each of us is both an audience and a participant. So the next time you turn on a light, take a step, or pour a glass of water, take a moment to see the invisible. To notice the hidden physics of ordinary life. It's not just science, it's the story of everything you do.